Hello all, I am Richa. I am a founding member of CTO Community and welcome all from our CTO Community core member like Prashant, Vijay, Gaurav, Sika. Many are there who is contributing here. And Gaurav is our speaker who is mostly continuing for our emerging technology first series for generative AI. And this any questions will be there. He will take further. But yeah, it is a new for everyone to start as a new beginning to explore the generative AI, what I can say. So over to you, Gaurav. I think you can continue and maybe if any questions will be there that you can go with your agenda.
Okay. Thanks, Richa, and welcome everyone to session number three, which is the session on AI agent. To be honest, we have been doing the first two sessions to reach here. Today, we are going to discuss the most talked about thing, and I'm going to come to it why it is the most talked. Few people have joined new. I will try to do a very quick recap of what we went through in session one, just a 2-3 minutes recap, and then we'll move to today's session. It's going to be slightly lengthy session. There's a lot to cover, so please be with me. And let me. We started with discussion of LLMs, right? We basically started discussion of generative AI. We talked about what is generative AI. We defined the bucket, and we said that we are only going to discuss generative AI in these three sessions. We went inside how the model is formed. We tried to understand what goes inside model transformer architecture. We said that there is no magic happening. There's no database lookup happening. It's all vectors, numbers, embedding. This was our session one. We tried to see that if somebody wants to do, we also went to do that. If somebody wants to do hands-on, where you can possibly go, you can go to Hugging Face. We saw the Hugging Face page where you can understand the model, you can download the model, you can, know the training data set and everything on the Hugging Face. So this was our session one, where we basically tried to, I would say, to open up LLMs, right? Or decouple LLMs or understand underlining architecture of the LLM, right? Once we were comfortable with that, we went to RAG. We said that, okay, LLM as such will not be useful to us other than we are asking a question, it is replying. How do we use in corporate use cases? We said that RAG is one of the most commonly used, case because LLMs have an outdated knowledge. They do not have outdated or knowledge around what is publicly available, right? It doesn't have knowledge about your company data, your corporate protected data, copyrighted data, which resides in your company, which is useful to your clients, to your employees, but not to everyone. So, one second. So, we said that how do we now add that knowledge, right? Which is relevant for our customers, for our people to work upon. Okay, and that's where we said just 1 second. Right, that is retrieval augmentation generation. Okay, with which you can augment your company's knowledge and your copyrighted documents to LLM. You can do the RAG architecture, you can do RAG implementation, and the model will be able to answer those questions around the data which it didn't have before. Okay, we studied we said that RAG is slightly old. Simple RAG doesn't help. So what are the advanced RAG mechanism? We talked about that. We talked about graph RAG. We talked about multimodal RAG, right? Now we come to agents, right? So basically we have understood the model. What are large language models? We have tried adding our own knowledge base. Now let's come to AI agents, right? So before I go there, let me just do a quick show of hand or, there is this question, right? That the models will take over human beings or, models will, take our jobs, right? So how many of you believe that is true, right? Or how many of you have analyzed the question? Right? Why is this question in the market? So let me start by asking, how many of you think it is true? You can in chatbot type yes or no in the chat window. Just say yes if you believe that AI can take somebody's job. Okay, and if you think it's a no, you can type no. Okay, we have one yes, two yes, yes. So that means AI agents already. If you are on yes, so you know that agents are quite capable. Okay, so I think that's a good thing. Typically, people start by no, and I try to show them that what agents can do. But here the group is trying to say yes. Okay, so I think that was my just judgment around that. So we all say yes, which means I think most people are thinking that agents can mimic human behavior. Okay, they can really think or act like humans, right? So how do humans work, right? How do humans react, right? So human, if I give you a goal, for example, let's say Richa has been in Bangalore for a very long time, and I am a newcomer to Bangalore. So I tell Richa, I'm visiting for 3 days. Can you help me plan an itinerary for Bangalore? I want to stay in a hotel which is under 3,000 rupees. And I want to do local sightseeing. Okay. So what will Richa do? So Richa has been given a goal. Okay. She needs to plan an itinerary for me. She needs to find the hotel. She needs to find the local places where I can go. She needs to arrange them in a sequence that she take care of my dependencies. For example, if my flight is landing at 6 o'clock and the hotel check-in is at 2 o'clock, she can possibly fit in something in middle, right? So a human, once given a goal, tries to break that problem into small tasks. It does a planning around that. Once you're given any problem, so this is a common example, but you can look at your any company problem, anything, you will try to break that problem by planning task around that. Once you have the task, you will put actions again that, okay, for doing hotel booking, I need to visit this site or I need to call this hotel. For sightseeing, I need to go to this tourism of Bangalore site and see that whether this is open on the day Gaurav is coming or not. Right. So once you have your task, you'll create action items around them, and then you'll start doing this action. To do this action, you'll need some tool to check hotel website to check whether you can book a hotel. Either you have to call up the hotel, so you need a tool like telephone, mobile number, or you need to go to some website. So basically, planning, taking into action, which is like uh, actions or tasks, then help of a tool, and then finally you need a memory. What is the output of one task? You need to use that, you need to remember that, and then do the next task. As I said, right, for example, if a hotel says we allow check-in only at 2, so you need to remember this 2 p.m. And when you're looking for sites, well, local sightseeing sites, you need to find the site which can, and my flight land at 6, so you need to remember 6 a.m. landing, 2 p.m. check-in, and try to fit something in the middle. Okay. So action, planning, tools, memory. These are the typical 4 things where human tries to, you know, uh, tries to achieve a goal, right? Is there anything else that we use? Any other thing that we use to solve a problem? Of course, intuition. I mean, those are different things. Like we use our intuition, not going that way. Trying to solve a problem, very mathematical problem, not something driven by intuition. Not saying that you have to consider Bangalore traffic, which Google cannot show. No, those kind of things. But something which is very concrete and workflow based, right? Now, an individual works like this, right? Suppose if I say, Richa, I want to do Bangalore and Mysore. So Richa will form a team. She might talk to someone who knows Mysore. So we all are used to working in teams as well, right? We can work in teams. Now for working in teams, we have certain pattern. Like in our companies, we see hierarchy. There is a boss or there's an architect which defines HLD. Then he gives to a lower level, like the next level, team lead, then team lead to developer, but it's called as hierarchy, right? It comes from top to bottom. And once you design, it goes from bottom to top, right? Hierarchy pattern, network pattern. Network means we talk to different teams. If you want to apply a leave or if you want to take additional loans in your company, you will go to legal, HR, right? So that is how we work in teams, right? Now let's see what is agent. Okay, what forms an agent? With this background, okay, we have understood human working. Let's try to see that do agents resemble something same? So I think most of you said yes. So that means agents are doing exactly same thing. Okay. They work on exactly same pattern. This is an AI agent. Okay. It has following functions. It can do planning. It can, create action plans. It can execute these actions using tools, and it can save the results in memory. So it perfectly mimics a human working model. Okay. And it does all this with the help of LLM. LLM sits at the heart of it. Okay. Now let's quickly look at the definition. Autonomous AI agents are systems designed to operate independently, making decisions and taking actions to achieve specific goal without requiring constant human supervision, right? Autonomously working, no human intervention needed. The prompt that I am going to give to Richa, the task that I give to Richa, you all can go home today and try giving the same prompt to Chat GPT. Plan me a 3 days Bangalore itinerary with so and so hotel rate, so and so dates, and you will get an exact itinerary from Chat GPT. So it has replaced a travel planner. Okay, you go to various people. For example, you analyze a stock. To analyze a stock, you might go to financial analyst who is very good at finances. AI agents can do financial analysis, right? So agents can mimic all such behaviors, right? Agentic applications rely on one or more language model. Foundation to this, heart of AI agents is LLMs as their foundation core, allowing them to generate adaptive responses and actions in real time. These applications manage states transition dynamically, constructing event change to response to specific user query and customized solution. Okay, which is how humans work, right? Okay, perception, gather the information from environment, data input, planning, plan, action, take actions, and learn. And they can improve themselves, right? So now let's look at what is the hype. We will listen to two recent keynotes. Okay, one is from Satya. I think in this Google, let me know if the voice will come. Actually, in our Teams, we do that voice thing. Here, the voice option was there or not? I think while sharing, I have to. So now you can see the Google tab, right? You can see Satya there, right? What are you seeing exactly?
Yes, we can see.
Yes. And can
The
you hear
demo
the voice?
shows the real opportunity with multimodality.
Voice?
Soon you'll be able to mix and match inputs and outputs. This is what we mean when we say it's an.
Sorry, you are getting voice?
So
Yes.
this is
We
Yes,
are
yes.
getting voice. This is Sundar Pichai, not Satya Nadella.
Oh, sorry. I'm sorry. The next one is Satya. Yeah. Sorry.
an IO for a new generation. And I can see you all out there thinking about the possibilities. But what if we could go even further? That's one of the opportunities we see with AI agents. Let me take a step back and explain what I mean by that. I think about them as intelligent systems that show reasoning, planning, and memory, are able to think multiple steps ahead, work across software and systems, all to get something done on your behalf, and most importantly, under your supervision. We are still in the early days, and you'll see glimpses of our approach throughout the day. But let me show you the kinds of use cases we are working hard to solve. Let's start with shopping. It's pretty fun to shop for shoes, and a lot less fun to return them when they don't fit. Imagine if Gemini could do all the steps for you, searching your inbox for the receipt, locating the order number from your email, filling out a return form, and even scheduling a pickup. That's much easier, right?
Okay, so that was Sundar. I think this tab now, can you see Satya now? Or the second tab?
No.
No.
No,
it's the same.
Yeah, I have to go tab by tab.
Yeah, you have to switch. Yeah.
Yeah. So now let's listen to what Satya says around that. Okay, and then I hope I'll be able to give the due importance to agents. Why I want you to all focus on that.
It manifests in three fundamental ways. The first thing is, I think computing interface, as we know of it, is fundamentally changing, right? Once you have a natural language, which is multimodal even, there is image, speech, text, video in and out. That means every computer interface is going to change. You have increasing reasoning capabilities. If you look at even what just came out with O1, it just gives you, whether it's planning, reasoning capabilities, right? For 70 years of computing history has been about digitizing people, places, and things and making sense of it. We now have a new reasoning engine to make sense of it. And then lastly, you can feed it more context, more memory. So you put all these three things together, you're building out a very rich AI or agentic world in which you are going to have these AIs or agents, right? There will be some AIs and agents that are personal agents. There will be things that will work in the context of a team, in the context of an organization or business process, or even cross-organization. So this rich tapestry of AI agents that augment everything built, right? So that's the other part. The entire digital infrastructure and tools that we today have get augmented in this agentic world with all these AI agents that we build using the scaling laws as the underlying force. Now, of course, it's great. All this technology is going to be there.
Okay, so that's about it. So I hope with listening to these two great leaders, you were able to, how important these are. Those who follow generative AI on LinkedIn, you will see that every other post is around agent 2025. All we are talking is about agent, agent, agent. So let's now go a little deeper. How do we build agent? What does it take to build an agent? What kind of framework do we need? What kind of coding do we have to do? Okay, let's talk all about that, right? So I think from a steps perspective, we are going to talk about these 4 steps. Planning is nothing but, as I said, simple English planning, what we say, goal-oriented action sequencing, decision-making, strategy development, handling dependencies, adapting to real environment, and anticipating and mitigating risk. Okay, simple. This is the planning phase of it. Tools. Now we are talking of computers, softwares. We're not talking of human. So when we talk of computer, the tools would be like API calling. If you need real-time data, you need to call an API. If an agent wants to, the Gemini, right, the example that Sundar was showing, right? So Gemini will need an API to Google Mail, right? So that it can, or to any other Amazon API where it can get the copy of the invoice, right? So that is called tools calling. Interfacing with external application systems. If you have heard of Salesforce, they are advertising Agent Force, which is their AI agent, okay, which can automate all the customer agent part of it. Decision-making knowledge bases. Sometimes you have to in order to make a decision whether to do this or to do this, you might have to attach it to the ground rules, which is the knowledge base inside your company. Okay, and some needs of communication collaboration. If you're building more than one agents, then they need to talk to each other. There has to be a mechanism by which they can communicate, share messages, and collaborate. Okay. Memory, as I said, you will have to save results at each step so that you can either come back to it or you can refer to it in that stage itself. So that's called memory. Okay, essentially needed. Now let's start talking about how do you build an agent. So to build an agent, there are many frameworks, and you can do native Python as well, right? You can choose not to use any framework and go natively with Python programming. But I personally prefer frameworks because it makes it little easy. Frameworks need little less coding. You have all the APIs, you have all the structure. From a learning perspective, frameworks are slightly simpler. So I follow 2 popular framework, or I use 2 popular framework, True.ai. I can go to show you a code of True.ai. And later on, if we do any other session, there was a hackathon where me and Shikha participated. That agent was designed on LangGraph and LangSmith. I can show that later on. Right now, I'll show you an agent design using True.ai. So each framework will have its own way of handling an agent. Now, True.ai handles agent as a independent entity who are given a goal. Okay, so you define an agent, you give it a background story that this is your role, this is what you have been doing. Okay, you need to achieve this goal. Okay, and then you build a crew around it. Crew is a team of collection of agents. Okay, so let's start with this. First, you define an agent. Agents are individual AI units with crew, each with specific capability or role. Okay, so your role is to do research. So you'll have to define a role, researcher role. Okay, then you have to give a task, what task it needs to do. Okay, you can have multiple agents as a crew. All the agents in crew can talk to each other. And then you have to define how will this crew work. Like if you have 3 agents, will they be sequential, hierarchical, consequential? Like you can define the working methodology. I'll show you the code. As I said, like generally, if you look at LinkedIn chats or anywhere, right, 4 frameworks come on the top. AutoGen is from Microsoft. Crew.ai is what I'm going to talk now. LangGraph is another one, which I said I can show you the code. SOML agents, this is from Hugging Face. So generally 4 or 5 frameworks are on the top. If you want to explore the entire agent landscape, you can go to this site, aienginedirectory.com/landscape. You can filter on what you need. So you can search what all agents are available. AI agent platforms, AI agent frameworks. So we are under frameworks. Okay, this is the icon of True.ai, which I was talking about. Okay, and this is the icon of LangGraph, right? But you have 96 other frameworks if you want to use. If you want to do productivity, these are the agents. Okay, so roughly there are 1189 agents. You can go to any of them: sales agent, personal assistant, data analysis agent, Web3 research agent, content creation. It goes on and on and on and on. Okay. All right, you can use any of these agents. Some are free, some are paid. So this website, I'll ping you on the chat. Very good website. It gets updated every minute, every time. There is another website called agent.ai. Okay, here this company keeps building agents. So you don't have to write your own exam. For example, you need an agent which can do video script generation. You give it a video, it generates a script. So you don't have to do coding. Just go and use this agent. Okay. So it has 1214 already designed agents. Okay. Industry analysis, recent LinkedIn post. If you want to analyze that, just come here, use that agent. Okay. I have personally not tried. I don't know whether this is free, paid, how it works, but I'm trying to tell you that there is no need to design agents for common things. Somebody has already done it for you. All the startups are coming around agents only. They try to target a specific area. For example, cursor.ai is an agent for coding, right? Lovable.ai. Similarly, all these actually, if you go inside, these are nothing but small startups. When you start analyzing the company, you'll figure out, okay, this is a startup specializing on this thing. This is a startup specializing on data analysis agents. And that is why so many startups are coming, because building a startup in AI, you can do a startup with very small team itself, right? You do not need huge teams because agents can do work for you. You do not need a sales team, just use this agent, right? That's where the concept of one-person company like Perplexity.ai, Anand Srinivasan, if you heard the name, I think Arvind Srinivasan, he has done it all by his own, one-person company. Okay. Then there is agent was another such thing, like, here also you have more than thousands of agents listed. Just use them. You don't have to build an agent on your own. Okay. But in once you decide, then how do you do is what I'm trying to tell you. So if you use Crew.ai as a framework, you have to define an agent. You have to give it a role. What is his role? What is the goal? What is the backstory and tools? Let's look at an example and then we'll understand more. Okay. So I am defining an agent. Okay. I'm calling it as a movie buff agent. What I'm going to do, I am going to give it a IMDb movie CSV. Okay. All right. And I will ask it to go to internet. Server.api key. I've removed the key due to recording. It will go to internet. Okay. So assume this agent is a champ. It has thousands of movie database. And I'm going to ask him, give me top 10 horror movies. So it will research from this CSV. It will read all the reviews of the movies inside. So it will read the genre, it will read the reviews. Then it will go to internet, double check it and tell me the movies. So you can understand I have designed a movie critic. Sometimes, when we have to find a good movie, you'll go to a person who watches hundreds of movies. In real world, we'll go to that person, tell me which movie to watch. Instead of that, you can come to this agent and get the best out of it. Okay. So how do we do that? Import. Of course, first import the library, define Crew.ai, agent task. This is Python coding. This is Google Colab. Okay. Agent task Crew.process. Okay. Define the CSV. Okay. Let's look at the main things, right? This is Crew.ai, agent task Crew process, which I told you. Crew.ai tool, CSV search tool. Crew.ai itself has given you a CSV search tool. Otherwise, you can use Python also. Okay. So this is an agent, right? I am telling him the role, movie expert, right? Which I said, you need to give it a role. That is, you are a movie expert. You need to give it a goal. This is your goal, the individual thing, right? Backstory. Okay. This is the backstory. Expert at understanding movie generating review. I don't know if Satish has joined the call. Satish, have you joined? Okay. So there is often a question, ki Gaurav, you talk so much about these things. This looks so much. How big is the code? So honestly, this entire code is none of the AI code, be it RAG, Gen AI code or agent, is not more than 10-15 lines. The core code. Okay. It is not something dramatic there we are going to do. And that is why I told you in the beginning that if you want to focus only on generative AI, even you can do coding. And I do hands-on session for people because it is not huge coding. This is it. The agent is defined. Simple. You define the agent in just one single line. If I were to put it in the same line, it will actually come in the same line. I have told him, you are an agent. This is the tool. LLM, I have defined OpenAPI, ChatGPT Turbo 3.5. That's it. And I'm hooking up to the LLM, use this LLM. Okay. This is the Crew.ai framework. Now I will say that analyze the movie based on, and this is my input prompt. Here I will give like what kind of movie you want to do. Okay. Thriller or romance, whatever you want, and suggest based on the rating, right? I run this command. Okay. This is where I run it. Okay. Get the crew to work. This crew, this is where we're defining the crew. I told you, right? Crew is a collection of agents. I just have one agent, but I could have more than one agent also here. This agent 1, agent 2, agent 3. Somebody is good at movie, somebody can critique the movie. Okay, this agent one says that, okay, this is a movie, but agent two can say, no, this is not a good movie. So we can have more than one agent. Now, you must have heard a very common example of sales agent. In our company, we have defined a sales agent, which is a collection of 25 plus agents working together. One agent will go and identify leads on LinkedIn. Other agent will summarize those, leads. Third agent will map those lead to our company's product. Okay. Fourth agent will create a summarized or what do you call customized selling thing for that client. Fifth agent will compose a mail. Sixth agent will follow up right back, right? So there are agents, series of agents designed to do that work. So that's called crew. Okay. If you use crew.ai, if you use lang graph, it will be done in an entirely different way. We'll not be doing it like this. Okay. So you define the crew and you make the crew to go and do the work. That's it. I am not running it, but if you run it, you will get a top 3 thriller movies, right? It takes one more call to open API, so it will consume some money. But this is a working code I can give you. All of you can put your open API. Open API, you need to pay $5. Otherwise, you can do Firefly free ones as well. Okay. It is a $5 monthly thing and it has X number of tokens. If you cross that, you have to pay more. Okay. But there are free also. You do not have to always go to open API. You can use Olama or Firefly. There are more free ones available as well. Okay, so this is an example of this. This is the entire code of an agent. We have designed a movie movie suggesting agent. Simple as that. Movie expert agent. Okay, like that we can have finance expert agent. Okay, those who are really interested in coding. Okay, those who want to understand coding can go to Awesome AI agent. This is a GitHub repo. Okay, people put the entire code. Okay, it has 16.7 thousand stars. Okay, this is whole bunch of code. Like you can just keep on scrolling down, right? There are tons of agent and you have the entire code available. Okay, all these are open.
Could you please share these links on the chat
Yes.
or maybe in the list?
I will do. Now I will take a quick pause. Any questions for a single agent before we start entering multi-agent scenario? Any questions so far?
Gaurav, I have one point to check. There are a lot of guardrails and other aspects need to be done, right? Especially when you're going for a production level. So how do you do that one? Will you be covering at later point of time?
Guardrail, actually, I'm not doing. I think I had one PPT, but I have removed that. Okay, guardrail is not covered in this. I typically do it in two ways. If you're doing a hyperscaler, AWS has a guardrail API. Okay, you can check that. No, I'm not covering in this one actually. We can talk offline. I can guide you how do we do.
Okay, good, understood. Yeah, thank you.
And there's an open source, of course. So one AWS has that, and open source has one. I'll show you that library, and I'll show you the code also. I think I can have I'll share the Python notebook of guardrail actually. I used to do it before, but it was a short topic, so I think I've removed it from the slide.
Oh, okay, fine. Yeah.
Okay. So I think guardrails. I didn't catch the name. I can see the name. Who was it?
I don't hear.
Arun. So that is another topic. This is ethical AI, responsible AI. That is again a very, very big discussion topic. Okay, how do you do ethics? How do you do responsible AI? What are the best ways to do? How to best build? That comes in a real world use case. If needed in future, we can do a session around it. I think I have slides already. It will be a 30-minute session only. There's not too much to show you code-wise, but yeah, we can do a 35-minute sessions to cover the responsible ethical AI part. It comes under that.
Okay, sure.
Yeah.
Thank you.
Okay, I'll keep going. So now, I think one thing you have understood that typically one agent doesn't make much sense, right? You need a combination of agents because we all work in companies. Basically, we all work as teams. We need teams. We are used to having huge teams, right? We need more than one people. Okay, we often end up saying, "Arey, ye ek jane ka kaam thodi na hai, to itna sara kaam hai," right? So we need more agents, right? We need a system where one agent specializes in one thing, other agent specializes in another thing, right? So that is known as multi-agent system. Okay, what Satya was showing right now in this, if you remember that he is even speaking. So there can be agents within company. There's an HR agent, there's a legal agent. When you raise, when you raise a claim, so HR agent will see whether it is in the policy. Finance agent will see whether it can be, it will do the actual invoicing and payment, right? So the companies which get centered around as multiple agents running. And then one company talks to another company, that will be another agent talking cross organization, right? He talks to that level. Okay. And I personally feel we might reach that level. Okay. So this is a serious technology. See, guys, technologies. He talks about personal agent of your own use, organizational agent. You have an HR agent, you have an IT agent, business process agent, which does the customer part, and cross org agents, right? So I think you must have in your career, technologies come and go, right? And we feel, okay, this is another technology, quantum, blockchain. But this is serious, guys. I mean, this is going to stay. And I think most of you already said yes, which itself means the criticality of this technology. You cannot ignore it. You cannot take this lightly. Okay. You have to understand this to be careful with the consequences of this. Okay. So with that, let's enter multi-agent system. So now multi-agent system, particularly for me, as I said, right, I generally work with frameworks. So I have explored multi-agent systems with LangGraph only. Okay, you can do it in multiple ways, but for me, LangGraph is a little more comfortable. Okay, I understand LangGraph easily, and I've done a lot of coding around it, so I find it a little easy to work with. But you can go ahead and explore other systems. Some concepts are the same. Okay, like for example, multi-agent system. So multi-agent system, there are 3 design patterns: network, supervisor, hierarchical. Then there are planning agents which are good at planning. Okay, so you will find these 3 you will find in every framework. Planning agent, reflection and critique agent. This is specific to LangGraph. Each type of agent is defined on a base of paper. You can click on it. It will give you the link. What is the IEEE paper based on which it is designed, and you can read that, right? Okay, so multi